Hello everyone, Shigu here, and today I want to talk about a major W for the open source community, that is DeepSeek R1. If you've been on the internet in the last few days, you already know what I'm talking about. R1 is this Chinese large language model that can be ran locally on your computer because it's open source, so you can download it and run it right here. Nope, you won't be running the DeepSeek beefy guy competing with GPT-O1. You won't be doing you can, you can, but like most of us won't. But you can run some distilled models. A distilled model is when you take a bigger model and you train a smaller one with the knowledge from the bigger one. So it's basically a dumbed down version of the big one. And they have available all the sizes. Here's the big boy with 400 gigs. So basically this number is the size of the model. If you multiply it by 1.2 is basically the amount of RAM that you would need it to have on your computer to run it like completely on GPU locally. It's gonna be fast, it's gonna be good, but no one here has 400 gigs of VRAM on their GPU. I don't have 20 4090s. We're gonna run some smaller models, and I want to show you guys about some of the differences, because right here they show some benchmarks, and as you can see, DeepSeek R1, the big boy, is competing with OpenAI O1, that is the other big boy. So it's winning, or it's a par with it for most of it. I'm not gonna talk about the cost or how they managed to make this be so good. You can read their paper; it's very interesting. But here you can see that it's very close, all of this. But if you see right here that people don't pay attention for this light shade of blue, it's a 32 one. This one we can run locally, and as you can see, it's not that bad. Look at this. It's not okay. It's far behind. You can see it's not as good as the big one, but look at it. Like for most tasks, this will be like great. You won't need to run the server side one. You won't need to give your data and anything for anyone, because I've seen some people talk about, oh my god, you're gonna send your data to China. That's so bad. Let's be honest. All my data that's flowing around for American companies is way worse for me than any data that China got on me. Like China doesn't, like, I only use products from China. Like this came from China. Probably my cups came from China. My headset came from China. Maybe this was made in China. But like they don't control me in the way social media does. Like and all, like how Google knows everything about my life, and sell me ads to it. Like I don't use anything from China that much, but I don't want nobody with my data. I wanna have my own thing. I'm gonna show you guys the easiest way that you can run this. It's not hard. Like I'm gonna show you my specs. As you can see, I have a okay. My CPU is a Ryzen 7 5700 X3D. It's very good. My GPU is this one right here, the 6750 from AMD as well. So this is my setup. It's not the big, and I have 16 gigs of RAM. It's not the best computer in the world, but it's very good. It runs everything that I want, and I can play with some native AIs. I was running my test bench beforehand, and I took some data that I'm gonna share with you guys. I just wanna say, if you are on Linux, I use Arch, by the way. So I'm just gonna run this command right here. It's a helper to download stuff on Arch Linux. So yeah, right here you have the models. I have two installed for some reason. I don't know why I have. You find it, Olama, and you install any of these. I already have installed, so I'm not gonna do anything. And then you just start your Olama service. So you're gonna do systemctl start Olama, and then it's gonna start. I already have started, so when I do this, it's up. If you are on AMD cards on Linux, you need to use this. If you do, you see, oh, serve start Olama, but this is a trap. Okay, don't fall for this. It doesn't read the service, the Olama.service, that you gotta edit to run with my specific card, because my card is not supported by Rock M, the AMD stuff. It only supports very few cards, so I gotta use one, performance of a near one. I gotta like override. So when I override it, this doesn't work. It doesn't read the service, Olama.service. You need to use systemctl. This won't work. You're gonna default to your CPU, and it's gonna run very slowly. But now that we have our Olama service started, we're just gonna do Olama run, and we're gonna write the name of one of the models that we want to run. Like, I have a few stalled. All of them are DeepSeek because of the test that I was doing. But I'm gonna run the 14 one. I'm gonna do Olama run, and right now all of my VRAM is gonna be taken right here. As you can see, 11 gigs of my VRAM are being used by it. So yeah, I'm scared that my recording is gonna explode. Probably I shouldn't have opened the bigger one that runs on my computer. I never tried to run this recording before. But tell me about yourself. And ta-da! It didn't even have to think, you know? Greetings, I'm DeepSeek, and it's running locally. As you can see, this spike right here, it ran on my computer, on device. No data to China. So we are good. We are local. But this is the 14 billion parameters one. It's not even this one that is listed here. But I made my own tests. As you can see, I ran all the models that I could run on my computer. I can run until the 32B1, but the 71, it has an error. But as you can see, the 32 one already took 7 minutes to run this prompt right here. 7 minutes. It's a long time for one prompt. So my computer and my GPU and the way that I have VRAM, the 14 one is the best that I can do. So this is a very acceptable size. It runs very fast, as you guys saw. Yeah, I just ran this one. So I ran a simple C code. I asked for all the distilled models, simple C code that I could run. So give me a C code for creating a binary file, opening it, writing 10 student structs in a row, each one with random ID and date of birth, after print all the students in the file of the terminal. Like, this is a very open prompt. It was not very specific, but I just wanted to let them think and how they could get lost. I don't even know if my English is correct in here. Sorry for any spelling mistakes. I didn't check beforehand. But the first three models, the 1.5, 7, and 8, they gave me non-running code. None of these codes I can't compile any of them. As you can see, there's a bunch of there's little X's here, and in the side you can see places that had a mistake. So like here, it defined a void init ID inside of a main, so you cannot do that. Another inside the main, he gave me two mains. Yeah, this code won't run, and this is an explanation that he gave me. So I could try to fix it, but I don't think, just for the fact that he gave me functions inside functions and two mains, I think the 1.5B one is not very good for like simple code. The 7B one is more promising. Like, it made mistakes that are more simple to refactor. So right here, the main returns int, but it just returns. So if I just put a 1 here, like, okay. And here is size off. The function, for some reason, the wrong ones here, so I just changed that. And student buffers, here he tried to put in a vector of 10, like 12 elements. So yeah, if I try to compile this, it's not gonna work. AB, he also had didn't understand how some functions work. Like hand, he tried to put like a min and max here, but this function doesn't take min and max. It takes non values. So he shouldn't have done like this, and he made a mistake. And the first one, that out of the box we can compile it, is the 14B. Is the one that I can run on my computer. Thank goodness. it probably is more promising than anything that we can do here. So if we compile this here, like GCC 14b, it's gonna give us an A out. So if we run this, he actually manages to write the 10 students in a file and print them to us. So this is my test for knowing their knowledge. So thank goodness I can run this one at a fairly good speed. So it can help if I want some basic functions. I know we will probably struggle with a little bit more, but this already helps. If you can only run from the 1.5 to 8, I'll be more careful. Trying to trust it. So out of the box, as you can see, none of the codes here will even compile. So yeah, and the good part, at least, is that the smaller ones are faster. So it takes less time to run. So if you want a very simple thing and you're not scared of hallucinations from AI, you can just use these ones like, oh, give me 20 names, 20 random names. This is a good case for this, you know? If you need things like that, it's a good way of using them. It's not completely useless, because I see some people around there saying, "Oh, you're not gonna run the full model. It's not good enough." But the small ones are also good. They have the use cases, and the fact that they are open source, you can put them whenever you want. I saw a guy running one of these models in a Raspberry Pi, and think with me, if you just want a simple assistant that just checks the weather API that you have, like a weather thing, and then it talks to you in a human manner. This is good for this. It's open source. You can run it. Since it's not a complicated task, it will be able to use that. So this is a good thing. You won't need to use your OpenAI keys and pay a fee to run some of these models. And if you have some more robust hardware, you can run some good models like the 32B. You can run in a 4090, in a 4080. And with all that, it's good enough, you know. Most of us don't need to use the big model all the time that we want. We always want the big ones, but it's not needed. But I managed to run the 32B here. It wasn't the best experience. As you can see, it took 7 minutes to do the same prompt. That's a lot of time for a prompt this small. And if I had a better GPU, it probably would be faster. But I don't. So we gotta do what we gotta do. It gave a way smaller struct that makes sense. I only asked for IID and a date of birth. This one, he made the date of birth 3 different things. So the code right here gets a little bit bigger. Here, he made functions to make the code simpler to read. So this one, here is where he creates the random students and writes them. It's inside the code. Like if you're here, you don't know what's going on, you can miss this. Only the comment to point it out. When you make a bunch of functions that work together, is better for your code. I'm not a big fan of clean code, but it gives more readability for your code. And also manages to use the rand function in the correct way, different from the smaller ones. Apparently, the second one took some liberties in the date of birth. There are some people that have not been born yet here. Let me check why this is happening. This one is trying to use the ctime function. I understand now what's going on, and is dealing with it wrong. I never used that function before, so I don't know why it is wrong. But yeah, he made a mistake here. And then I ran it also in the cloud, the same code, and of course it's gonna work. I'm just gonna overwrite this one here. So yeah, if we run the one given by the cloud one, it's more likely that everything's gonna work out of the box. I didn't even read the code. It's a smaller code. It doesn't try to deal with minutes and date. So that's one of the things that probably made it one from the 32B. I think this is a very good step forward in AI. People being able to run their local AIs. And such a good one. We could do that before, but now it's a very good one that is competing with one of the biggest ones out there, and that's a very good step for humanity. Because we gotta think in the next few years, more people will be able to have more VRAMs on their GPUs, and it will be more accessible. So I think more people will be able to run this, and the models will be better. So yeah, I think this is very good. That's all I wanted to say for today. Run your DeepSeek. Don't send your data to China, and that's about it. Bye bye.